Hey, what's up guys? So I got myself a nice new shiny set of upgrades for my Hover Things Flip FPV frame. Up till now I've been using Cobra motors, the 2814 850 kV motors on this guy on 4S. They've served me pretty well. They've held up and all that good stuff, but after seeing the video that Patrick and Leslie put together for the new Multirotor line of motors, I've been itching to get a set ever since. So in the process of swapping motors around, I thought I'd do my own little video review, not so much into the technical details that Patrick has already gone through in that other video, far better than I ever could. Just kind of show you guys what I've already taken a liking to with these motors and point out a few things that I thought were interesting. While I'm at it, I'd like to give you guys a good comparison because these two motors stack up closely to each other in the specs. The real difference between the Cobra and the KDE motors, the Cobra is a 850 kV motor and the KDE motor's a 775 kV motor. So first things first, man, this thing is a solid hunk of smooth, awesome. You spin this guy around on your fingers and it is just so smooth, and the quality of materials is very tangible. So one thing you'll notice when you plug these guys into your ESC is they actually come with real 3.5 bullets, not those crummy little things we always use. Of course, these will make for a better connection and a better transfer of power. Soldered to these bullets are some nice long leads you could have running down an arm, around the arm a few times, way down into a mainframe, cut it off down there, probably still have enough left over to make a lasso for the next time you get a heli stuck in a tree. Now back to the motor instead of the things dangling from it. Top and bottom of the motor chock full of holes to mount it on whatever you want and to mount whatever you want to it. Now to something I'm quite fond of. The KDE motor has a collar at the bottom of the shaft on the bottom of the motor with a couple set screws that set screw into two flat spots on the main shaft, which is fantastic. Most other motors, like the Cobra, still have the snap ring. I hate the snap ring. It's a giant fuss every time I want to take it off of there to take a look inside the motor for something that might be lodged in there. Replace a bearing, replace a main shaft, anything really that requires getting it off of there. KDE really resolved this with this little collar. It really makes it much easier. And of course I'm too cheap to go out and buy the actual tools required to take off the snap ring, so I usually just grab a hold of it with my pliers and hope for the best. Now once you get the motors apart, you're gonna see on the inside of the bell how well machined everything is. The magnets are actually locked in there with material, not just epoxy. It's very well built. You're also going to see the balancing epoxy in there that they computer balance these puppies with, and as far as I can tell, it is perfectly balanced. They run silky smooth on my Flip. Something else that contributes to it running so smoothly is the oversized triple stacked bearings. You can't see it too well in the picture, but there's a line back there behind the first bearing where the other one butts up against it in the back. And then there's of course the one on the bottom making three. This allows for a much better distributed load across those bearings, and they're going to hold up a lot better for you. Back to balancing real quick, you'll see my cheesy attempt at trying to balance the motor can on the Cobra motor here. It's a non-issue with the KDE motor because of that balancing epoxy, and I didn't feel comfortable doing epoxy myself in case I goofed it up and added too much and screwed up my motor permanently. With the motors put back together here, I thought I would show you the difference between a prop being cinched down between two smooth surfaces and the same prop being cinched down on the KDE motor where the prop adapter has two grooved surfaces that meet the prop. Now with the Cobra motor, the prop adapter has to put a real good squeeze on the prop before it even gets in the air, which is going to increase the amount of stress on that prop throughout a flight. I've seen plenty of guys have props fail in flight because they cinched them down too hard on systems like this where they didn't know how hard they really needed to clamp down to get the prop to hold. With the KDE prop adapter, there are grooves on the washer sitting on top of the prop and the surface sitting underneath of it, and all I had to do was cinch it down as about finger tight as I could do, and that's all the more it needed. I didn't have to get out a tool to tighten up those props at all. Moving along here, I did a little bit of data recording with the Hyperion RDU. The goal was to see which motor would outperform the other given the same prop, same battery, same ESC at the same RPM, see which one would pull more amps at a given RPM, see which one would heat up more, that kind of thing. In a nutshell, both of the motors did really well. There wasn't a massive difference between the two. They're both really good motors. But the KDE did prevail in any given RPM range. It would pull slightly less amperage, which is good. That adds up at the end of the flight when you're looking for flight time on a camera ship and you're picking up weight. It's going to add up. On that note, the weight between the two different motors is only a difference of about 5 grams. The lighter of the two being the KDE motor. So between the current consumption and the weight of the two motors, the KDE comes out on top. But in a much more massive way, the KDE motor is a specimen, especially when you hold something like the Cobra or any other motor I've ever held in my hands. Next to this motor, you're really going to feel the difference between the two. So I'm going to quit talking now and let you guys enjoy some glamour footage of the new KDE powered flip FPV frame out at the park, catching some cool clips. Guys, have a good one.